In this question, there's a man who's driving along, and he sees a speed trap, so he slows down. During the time that he's slowing down, he travels 81 meters in a time period of 3.10 seconds. His final speed is 21.6 meters per second. But we're asked, was he exceeding the speed limit before he began braking? So this is a question where we want to restate the question as part of our solution, as part of our visualization. We're restating it. So, was v not x greater than 65 miles per hour? Okay, so restating the question doesn't have to be difficult, but it should involve finding a specific symbol and what you're going to compare it to. Okay, if it's a yes-no question, it involves a comparison, and we want to know specifically what we're going to be comparing at the end. So we want to find v naught x. We expect v naught x to have a positive value because we picked to the right to be positive, and he was traveling to the right at the end. And then we expect the units to be meters per second when we're solving this in our SI units, and then we're going to have to do a unit conversion at the end. So part of our plan is to say take 65 miles per hour and convert it to meters per second. We can also look at our equations. We can say, look at this equation. And this equation. Looking at these two equations, we could say, well, we know x and x naught. We don't know v naught x. We know time. We don't know the acceleration. We do know time. We have two unknowns in there. And then we look at this equation. We know this, and we know the time, and we don't know these two things. So here we've got a system of two equations and two unknowns. So we could solve the problem this way. However, we can do this a different way that does not involve using two equations and two unknowns. We look at our equation sheet. We also see this equation here. And we know delta x, and we know the time, and we know the final velocity. So this equation here just has one unknown in it, and we can solve for that. 81 meters. So this was part of our plan. Okay, and now we're going to execute the plan here. So now we're starting with step 4. Execute the plan. 81 meters over 3.10 seconds equals v naught x plus 21.6 meters per second divided by 2. And so now we can multiply both sides by 2. And so 2 times 81 divided by 3.1 gives us 52.26. And that'll have units of meters per second equals v naught x plus 21.6 meters per second. And we're going to subtract 21.6 from both sides. And we get 30.7. Okay, so this was a quicker way to find Vx. We could have solved using our two equations, two unknowns that are shown here, but we found a different equation that allowed us to avoid doing that. Wouldn't be anything wrong with that. But we didn't have to. We're not going to put a box around this. That's not our final answer, because we need to do a conversion here. We need to take 65 miles per hour, and it's much better if we're doing a conversion to write it like this than to write mph or to write a diagonal slash for miles slash hours. This way we can do the conversion and say 1 mile is equal to 1,609 meters. And we can say that 1 hour is 3,600 seconds. 65 times 1,609 divided by 3,600 is 29.1 meters per second. Hours canceling, we get miles canceling. There we go. So, since 30.7 meters per second is greater than 29.1 meters per second, he was speeding. All right, and that is our answer right there. Okay, not just yes or no, but what did we use to make that decision? Is the solution complete? Yes, we were only asked for that yes or no question. If we had stopped here, the solution would not have been complete. Is the sign of the answer correct? Well, the sign of this value is correct. We expected it to be positive, and it was, and we expected it to have units of meters per second, and it did work out that way. And is the magnitude of the answer reasonable? Yes, he was going just slightly over the speed limit before. If this had come out to, say, 307 meters per second, that would have been a pretty unreasonable answer, because that would have been over 600 miles per hour. All right, so yes, he was speeding.